Hello everybody, this is Coach Meidenbauer. Welcome to my video here in AP PreCalculus 2.6 competing function model validation. What we're going to be doing here is we're going to be comparing some stuff of old stuff, a little bit of newer stuff, and putting it all together. So before we get this video started, do not forget to like and subscribe. So first up, we just have this little table right here helping us figure out what's linear, what's quadratic, what's exponential. Linear, the first differences are constant. Second differences are constant, and the outputs may repeat. And then exponentials, the outputs are proportional. So we're going to look at these three things. We've done this before earlier in Unit 1, but now we're adding in the exponentials. So we're adding an extra variable to it. So if we look at number 1 right here, I first think, are these multiplying to get to a number? No, so it's not exponential. For my outputs, of course, looking at my f of x. I do say my x's are all constant, so I can go ahead and just look at these and go, okay, I'm going up 2, down 6. Okay, first set of differences were not constant, so the next set of differences are down 4. Those are constant, so I got me a quadratic here. All right. Moving on. Okay, next one right here. I just look. Is it multiplying for the output values? Yes. What are they doing? They're multiplying by 2. So this must be exponential. Right here, not multiplying. But if I look right here, I'm going up 2. These are not time signs. Those are plus signs. Up 2. So hopefully it's not on mute if you're watching this. Those are all up 2. So this is going to be linear. We've talked about residuals before. Residuals are just the output, the actual output value minus predicted value, which is on the side over here. But let's talk about data sets with that. So in a regression model for data, the residual is the actual minus the predicted. The model for the appropriate residual plot has no pattern. So if we have a model and we have a residual plot for various types of x values, if there is a pattern, the residual is no good. It's not a good model. Okay. If there is no pattern, that means we have a good model. What does that mean by model? Like, let's say that we have a table and we're plugging in like a regression. If we look at the residuals of all of those and then there's a pattern, it was a bad regression. Okay. So looking at this one right here, is there a pattern here? I mean, people might argue that look at all the ones up above, but it's like below 0, above 0, above 0, above 0, below, above, below. Like there's no pattern here. So this is an appropriate model. So there's no pattern. Oh. No pattern. So we have the model is appropriate. Looking at this one right here, you can see that it does like decrease and then it increases a little bit and increases more. So there is a pattern here. So I see a pattern. Which means that this model is not appropriate. Okay, moving on. All right, so this is what we call a cop-out on a video. I'm not going to do this problem. This problem is very similar to the problem that we did in 1.13.14 video. So you need to go look at that video, and this will model how to do example 2. So I advise that you try example 2 on your own here, and then you pause the video, and then you can unpause it, and I'll have the answers in like 10 seconds. So giving you a chance right now to go ahead and pause it. Okay, if you've been paused by now, you just don't care and you just want the answers. That's what I'm good for. So we're going to get W of x is 3.34 plus 0.8x. Is that what you got? Oh my gosh, that's awesome. Good job. Proud of you. For B, we're just going to plug in a 2.5 into my model up there. And I got 5.34 kilograms. Is that what you got? Man, you're rocking it. You're eating, as the kids say these days. I'm also eating, but my eating creates. I'm going to not get into that. Residual, just to remind you, it's actual minus predicted. I do have the predicted up here. The actual was 5.5. So for the residual, choose R for residual, not range. R for residual, 5.5 minus 5. Sorry, I'm just looking over my notes. 5.34, which gives me 0.16. And this is an underestimate. So our residual here for this particular point is an underestimate. All right, good job. You did great. All right, example 4, a group of AP PreCalculus students has used a set of data to create linear, quadratic, and exponential regression models. After creating the 3 models, the students created a residual plot for each model type, see above based. So you can see the models right there. Which of these is appropriate for the data? So we have the linear on the left, the quadratic in the middle, and the exponential on the right. Which one of these is an appropriate model? Exponential. Why? Because there's no pattern. Okay, so there you go. That's the notes for 2.6. Don't forget to like and subscribe.